In this video, we'll look at how we can apply Lechat's principle to predict the effect of changing various factors on a system that is at equilibrium. Lechat's principle is a tool that allows us to look at the effect of changing concentration, a change in volume, which is associated with a change in pressure for gaseous systems, and the change in temperature. Lechat's principle states that when a system is at equilibrium and is subjected to one of these stresses, the system will respond so as to minimize the effect of the stress. Now remember, the Lechat's principle is simply a tool. The reason why an equilibrium system shifts with these various stresses is a result of temporarily the forward or the reverse rates are faster. This can be the result of an increase in concentration on one side of the reaction over the other side, and so temporarily the forward or the reverse rate is faster. Or in the case of change in temperature, this would be associated with changes in conditions related to Gibbs free energy. Ultimately, it would be connected to the fraction of particles that has sufficient energy to react. Well, let us look at these various examples here. In the first case, the addition of gaseous dinitrogen monoxide. So this is one of the reactants. Effectively, we've increased the concentration of one of the reactants, so temporarily the forward rate will be faster than the reverse rate. Lechat's principle tells us, though, that an increase in concentration of reactant, the system will respond so as to minimize that effect and thereby decrease the concentration of the reactant. So either way, we know that the reaction will shift to the right. So what I will do here is I'll go right-hand side to suggest the shifting to the right. Removal of gaseous nitrogen dioxide. So we're removing one of the reactants. So temporarily, actually, the reverse reaction will be faster than the forward reaction. Lechat's principle tells us that we've reduced the concentration of one of the reactants, the system will respond so as to increase that concentration, the reaction will shift to the left. So left-hand side. Addition of gaseous nitrogen monoxide. So we've increased the concentration of one of the products. So temporarily, the reverse rate will be faster than the forward rate. Again, Lechat's principle would say we've increased the concentration of the product. The reaction will respond so as to minimize or decrease that concentration of the product. Therefore, the reaction will shift in the left, so left-hand side. Increasing the temperature. Now, as you know, in predicting the effect of temperature, we have to know whether or not the reaction is endo or exothermic. And one of the things that I've commented on is that an increase in temperature favors the endo direction. In a sense, that is a statement of Lechat's principle. Well, we've just said increasing the temperature, that will favor in the endothermic direction. We can see, indeed, the forward direction of this reaction is endothermic. Therefore, we would expect the reaction will shift to the right. Addition of helium gas, constant volume. So the idea here is we're adding an inert gas. No change in volume. There are no changes in the relative concentrations of the reactants and products. There is simply no effect or no change in this particular case. Now, sometimes when you add an inert gas, this could result in a change in the volume of the container, and so that should be considered a change in volume and responded to accordingly. Notice F says decrease in the volume of the container. So decrease in the volume results in an increase in pressure. Lechat's principle would tell us that essentially all the reactants and products are too concentrated with this decrease in volume. Therefore, the reaction will shift in the direction of fewer moles of gaseous particles. So in this case, the reaction will shift to the left-hand side, the side with fewer gaseous moles of particles. Now, this is one way that these questions can be asked, but I also want to point out that another way of asking about this is rather than just talk about the shift, we can talk about how quantities will change. So for instance, let's just look at A again. Addition of gaseous dinitrogen monoxide. So we say the reaction is going to shift to the right-hand side until a new equilibrium position is established. And so temporarily, as I say, the forward rate is faster than the reverse rate. So that additional amount of N2O will be brought down. We would also find that the quantity of NO2 would decrease because the forward rate is temporarily faster than the reverse rate. And of course, the amount of nitrogen monoxide would go up. Another thing to consider, for instance, is at D, the fact that we've increased the temperature. This actually results in a change in the equilibrium constant. So none of these other changes, when there is a shift, results in a change in the equilibrium constant. But we see indeed for D, the equilibrium constant will change. If there's a shift to the right-hand side, it means that there's now more product present than there was before and less reactant. So therefore, in this particular case, we would expect that there would be an increase in the equilibrium constant. So that can be easily worked out in the sense that you always remember that the equilibrium constant is essentially the concentration of the products over the concentration of the reactants to the appropriate superscripts based on the coefficients in the balanced equation. I hope this short video has helped you review a little bit concerning Le Chatelier's principle.